Welcome to The Explainer. Today, we are literally digging into a critical issue, soil erosion. It's this quiet, almost invisible process that has a massive impact on our world and, our ability to feed ourselves.
And the name itself is pretty telling. Erosion comes from the Latin word erodere, which actually means to eat away. And honestly, that's the perfect description for this slow, relentless process.
Now, you might not see it happening day to day, but this is a silent crisis. It's a real threat to our food security and the health of our environment, all because it's stripping away our most fertile, precious topsoil. So let's break down how this whole thing actually works.
Okay, so here's the thing. It doesn't really matter if we're talking about a single raindrop or a powerful gust of wind. At its core, every single type of erosion follows the exact same fundamental three-step sequence. It's super simple, really. It all starts with detachment, where a soil particle gets knocked loose. Then comes transport, where something like wind or water picks it up and carries it away. And finally, you have deposition, which is just when that wind or water runs out of steam and drops the particle in a new spot. Detach, transport, deposit. That's the whole process in a nutshell.
So who are the main culprits in the story? Well, there are two big ones that do most of the work: water and wind. And each one has its own signature way of getting the job done.
On one side, you've got water. Think about the impact of raindrops hitting the ground over and over, or the force of runoff carving channels in the earth. On the other side, you have wind. This is a huge deal in drier areas, especially where there isn't much vegetation to hold the soil in place. The wind just comes along and whisks those loose particles away.
Let's zoom in on water erosion for a second. It can literally start with a single raindrop. But that one drop hits the ground like a tiny meteor, bam! It creates this small crater and splashes soil particles all over the place. This is called splash erosion. And not only does it move soil, but it also clogs up the pores in the soil surface, which means less water soaks in and more of it runs off.
From there, once that water starts moving across the surface, it can escalate to what's called sheet erosion. I love this description, the invisible thief. Why? Because it's this thin, uniform layer of the best topsoil that gets washed away, almost without you noticing. It's so subtle, it's one of the most dangerous forms of erosion.
But, eventually that invisible thief starts to leave tracks. As that runoff water concentrates, it begins to cut small but visible channels in the soil. We call these rills. These are the first real red flags you can see with your own eyes. Now, you can often just erase them with normal plowing, but that doesn't mean the problem has gone away.
Because if you ignore those rails, the tracks become permanent scars. They can deepen and widen, first into what we call ephemeral gullies. These are big enough to be a nuisance, but you can still cross them with farm equipment and till them smooth. The problem is, they just come right back in the same spot after the next rain. Let that go on, and you get classic gullies. Deep gashes in the landscape that are way too big to fix with tillage. At that point, you're looking at some serious destructive damage.
Okay, so that's water. Now let's switch gears and talk about wind. The way wind moves soil is also broken down into three different mechanisms, and it all comes down to the size of the soil particles.
Now, take a look at this chart. This is what's really interesting. The vast majority of soil moved by the wind, we're talking up to 75%, happens through just one of these processes. It's called saltation. So what is saltation? Just picture medium-sized soil particles bouncing and skipping along the ground. That's it. But here's the cool part. It's a chain reaction. As these bouncing particles land, they smash into the ground and kick finer particles, like dust, high up into the air. That's called suspension. At the same time, they nudge the larger, heavier sand grains forward, causing them to roll along in what we call surface creep. So really, saltation is the engine that drives the other two types of wind erosion.
So this all begs the question, what are the factors that determine how bad erosion gets? Let's take a look at the conditions that can push the land right past a critical tipping point.
Well, there are several key factors that can really accelerate erosion. Think about it. Less vegetative cover means more exposed soil. Steeper, longer slopes mean water can pick up more speed and do more damage. The soil texture itself matters too. Silty, fine soils are way easier to move than heavy clays. And of course, just the raw power of the weather. More intense rainfall and higher wind speeds mean more energy to tear the soil away.
And the impact is significant. See, erosion is a selective thief. It doesn't just take any old soil. It takes the best parts, the light, fine particles, and the organic matter where all the nutrients are. And the nutrient loss is just staggering.
Look at this. For every single metric ton of organic matter that gets washed or blown away, you can lose up to 60 kilograms of valuable nitrogen. That's a massive blow to productivity.
This brings us to a really crucial concept, the soil loss tolerance, or what we call the T-value. Think of it as a sustainability threshold. It's the maximum rate of soil loss that can happen before you start degrading the land for the long term. For a lot of good farmland, that T-value is around 5 tons per acre per year. Once you start losing more than that, you're officially losing soil faster than nature can replace it. It's completely unsustainable.
But, it is not all bad news, not at all. We actually have a powerful toolkit of conservation practices that are specifically designed to fight back against erosion and protect our soil.
And these are some of our best solutions. We're talking about smart farming techniques like contouring, where you farm across the slope instead of up and down it to slow down the water. We can build terraces to turn a steep hill into a series of steps. We can plant cover crops during the off-season so the soil is never left bare. And for wind, we can plant windbreaks, rows of trees that literally break the wind's force. Every single one of these is designed to do one thing: reduce the energy of wind and water right at the soil surface.
Ultimately, putting these strategies into practice isn't just about saving dirt. It's about ensuring that we can sustainably use our most fundamental natural resource for generations to come. It's about stewardship.
So I'll leave you with a final thought to chew on. It takes nature millennia to form just 1 inch of topsoil, but all of that can be lost in a single storm. So the question we have to keep asking ourselves is, are we really doing enough to hold our ground?